Okay, this is a lesson on work. This is also my sort of just introduction to physics, and I will reveal for those of you who know physics better than I do how little I know, but here's some basics. Work. Okay, start with velocity. Velocity is measured in meters per second, m over s. And this tells you how fast you are going. That is, how many meters do you travel every second. Acceleration. Acceleration is meters per second, or meters per second squared. And this says how many meters per second you speed up each second. So if every second you're going 10 meters per second faster, now I'm going 10 meters per second, now I'm going 20 meters per second, now I'm going 30 meters per second every second, then that is 10 meters per second squared, which I think is pretty fast, but whatever. Force. What is force? Force is measured in kilograms times meters per second squared. Kilogram meters over second squared, also known as a Newton. Physicists, anytime they do anything, they give it a new name because they want to use as few letters in writing things down as possible. Anyway, this measures a push, a force is a sort of a push, by how much it can accelerate a mass. So, if you are pushing something very, very heavy and you're accelerating it slowly, or if you're pushing something very, very light and you're accelerating it quickly, that could be a significant force. If you want a big force, you have to have the sort of thing that can take a heavy thing, a lot of kilograms, and accelerate it very, very rapidly, many meters per second squared. And right, anyway, that's a force. Now, work is measured in Newton meters. That is, well, the newtons are kilogram meters per second squared, so this is kilogram meters squared per second squared. And this is it measures how far you have exerted your force. So if you exert a force for a certain distance, a force of some number of newtons over a certain number of distance of meters, you multiply them together, that is how much work you have done. Just standing in one place holding a box, that's exerting a force, and that could make you tired, but that doesn't count as doing work. Doing work is lifting that box against the force of gravity. So, for example, Earth's gravity accelerates objects downward at 9.8 meters per second squared. So if we lift a 30 kilogram mass up 4 meters, how much work have we done? Well, what is our force? Our force is mass times acceleration. Kilograms times meters per second squared. So the force that we are doing, the force, well, let's say, of that box pushing down on us, things are always equal in that sense. What we are pushing up on the box is the same thing. I assume it's a box. The force is the mass times acceleration, which is 30 kilograms times 9.8 meters per second squared. And that gives us, let's see, 30 times 9.8 is 294. This is 294 kilogram meters per second squared, or 294 newtons. Now that's how much force is either you pushing up on the box or the box pushing down on you. These will be equal. Now we're going to push it up 4 meters, and the work is going to be force times distance, which is going to be 294 newtons times 4 meters, which is 294 times 4 is 1176. 1176 Newton meters, also known as 1176 joules. And this is the idea, work, and basic units of physics.